So in today's class, we are going to talk about motion in vertical circle. We are going to talk about motion in vertical circle. Okay. So what exactly is motion in vertical circle and what are other things related to that? Let us talk about it and let us study. So this is a circle as you all can see. Obviously, if it is a circle, then it will have one center. So this is center O. Now in this vertical circle, what is happening? There is a mass. There is a mass M. Okay. And this mass is connected by a string. Length of the string is R, which is radius of the circle also. Okay. So now let me write a few things before we start the description. In the given situation, an object of mass m, small m is connected to a string of radius r. Okay, string of radius r. The other end of string is tied to the center. The other end of string is tied to the center, obviously of circle. Okay. Now let me give them names. So the lowest point is A, then the another point is B, then there is C, and then there is D. So A, B, C, D are the 4 points in the circle. A, B, C, D are the 4 points on vertical circular path. Someone's mic is unmuted. Please mute it. Someone's mic is unmuted. Please mute it. Please. Okay. Now pay attention, everyone. Pay attention. At point A, we are giving velocity VA to the particle. At point A, velocity VA is given to the particle or object, you can say, is given to the object such that it is just able to complete vertical circle, such that it is just able to complete vertical circle. All right. So VA velocity is given at point A, and due to that velocity, object will complete the vertical circle. So it will pass through point B, point C, point D, and then it will return back to point A, and then the motion will continue. All right. Any doubt, any questions so far, anyone? No question. That's a good thing. All right. So let us move further. Let us move further. All right. So what I am doing, I am applying MEC between point A and C. So when the object will reach at point C, it will have some velocity. Let me call it VC. So by MEC between point A and C, by MEC between point A and C. Okay. So when we apply MEC between point A and C, what happens? Let's see. So PEA plus KEA is equal to PEC plus KEC. All right. Now this is reference line. This is reference line. So if reference line is passing through point A, that means at point A potential energy will be 0. At point A potential energy will be 0, right? So PEA is 0 plus KEA, that will be half mVA square is equal to PEC. If you observe, the height of point C from A is 2r. So mg into 2r plus KEC, half mVC square. All right. If you simplify this, you get VA square is equal to VC square plus 4GR. Okay. If you simplify this, you get VA square is equal to VC square plus 4GR. Right. Now there is a problem which we are facing. And problem is what? There are two variables. One is VA and other one is VC. So there are two variables, but there is only one equation. There is only one equation. So what do we need to do? We need to create one more equation. All right. And to create that one more equation, what we are doing, we are going at point C and applying Newton's second law. So obviously when the object is reaching, the string will be like this. So by Newton's law, at point C, so mg is acting downward, Tc is tension at C is also acting downward because tension always acts along the length of the string, right? So mg plus Tc is equal to mvc square by r. mg plus Tc is equal to mvc square by r. Correct. So this is our second equation. This is our second equation. Now we want the object to just complete the circle. We want the object to just complete the circle. So if it is just completing the circle, tension at point C will be 0. Okay. Tension at point C will be 0. Why? Because it is just completing the circle. Okay. So that gives us VC is equal to root of GR. That's a major breakthrough. We got value of VC. Let us put that in equation 1. So putting VC in equation 1. So when we are going to put it, we are going to get VA is equal to root 5 GR. This is very important. So VA comes out to be root 5 GR. All right. So let me write it also. So basically, when an object is tied to a string, and we want it to complete the vertical circle, then the velocity required to be given at the lowermost point, is root 5 GR. Okay, everyone, please note. Please note. Please note. Okay. Now, if we want to know how much, acha, we have got TC also. TC is 0. VC is how much? Root GR. Okay. So we got VC also, we got TC also. How much is TA? Pay attention. So TA will be acting upward because tension force is pull type force and string tries to pull, it ends. So TA will be upward, mg will be downward. So what we can see is TA minus mg. So this is F resultant. TA minus mg is F resultant, and that should be equal to how much? mv square by r. So m into VA square by r, and that gives us, if you put values of VA and solve, this gives us TA is equal to 6 mg. This gives us TA is equal to 6 mg. Okay, please note everyone. Please note. Please note. Please note. All right. All right. Now I want you to apply MEC between point A and B and give me the value of VB and TB. Everyone, please do that. Apply MEC between point A and B and give me the value of VB and TB. Do that quickly. I'll answer your question, Komal. Okay. First, you get the value of TB. You are taking too much time, everyone. Okay, pay attention. Now I am going to apply MEC between A and B. So PEA plus KEA is equal to PEB plus KEB. All right. So PEA is 0. KEA half M into root 5 GR whole square. Correct. Root 5 GR whole square. PEB MGR KEB half MB square. So that gives us VB is equal to root of 3GR. That gives us VB is equal to root of 3GR. Right? Now let us see that how much is tension. So at point B, everyone please pay attention. At point B, Mg will be acting in this direction. Tension will be acting in this direction, Tb. Now you can see that tension and Mg both are mutually perpendicular. Both are mutually perpendicular. And as they are mutually perpendicular, there will be no component of Mg along tension. Okay. So basically, Mg has no role at point B in providing centripetal force. So Tb will be mvb square by r only, and that gives us Tb is equal to 3 mg. That gives us Tb is equal to 3 mg. Okay, so this is interesting. Now pay attention. Pay attention. Vb is how much? Root 3 gr. Tb is how much? 3 mg. Similarly, as the D point is also at same height, so TD will be same as 3 mg and VD will also be root 3 gr because height is same. If height is same, that means potential energy will be same, and if potential energies are same, then kinetic energies will also be equal at point B and D. So that's why VB is equal to VD and TB is also equal to TD. So basically the point which is to be noted is that B point and D point, as they are at same horizontal level, they are almost similar for all practical purposes. Their speeds are equal. VB is equal to VD. Tensions in the string at that point is also equal. So what is the difference? One point comes when you are going up or object is going up, and one point comes when the object is coming down. That is the only difference. If you change the direction or reverse the direction of motion, then D will come in place of B and vice versa. Okay, that is the only difference. That is the only difference. Now, if you look closely to the values of VA, VB, VC, VD. So VA is root 5 GR. VB is root 3 GR. VC is root GR. Correct? So what special thing we are noticing that as we are going up, speed is decreasing by 2 GR within the root. As we are going up, speed is decreasing by 2 GR within the root in every quarter circle. Okay. Also, if you look closely to the tension, TA is equal to 6 mg, TB is equal to 3 mg, TC is equal to 0. That means tension is decreasing by 3 mg in every quarter circle. Correct? So let me write this as star point, and you also note that. So in a vertical circle, star point. In a vertical circle, as we go up, as we go up, speed decreases by speed decreases by 2 gr within the root. This is not very technical statement, but this is helpful for us in exam. Okay, so technically this is not very decorated statement. What do you mean by decreases by 2 gr within the root? But those who are smart, they understood that what is the meaning. So in a vertical circle, as we go up, speed decreases by 2 gr within the root, and tension decreases by 3 mg in each quarter. In each quarter. Okay. So with each quarter, as we are going up, tension is decreasing by 3 mg. Tension is decreasing by 3 mg. All right. Understood? So you can use this fact directly to solve questions. You can use this fact directly to solve the questions. Okay, it is that simple and good. Okay, so let me give you a question so that I can see how you are able to use it. Question. Very nice. So this is point A, and VA is given as root of 10 GR. This is B, this is C, this is D. So what you need to find is, and radius is R. What you need to find it? Find number 1 VB, number 2 VC, number 3 VD, number 4 TA, number 2 number 5 TB, number 6 TC, number 7 TD. Please solve quickly. You should be able to answer it just like this. Solve quickly, everyone. Hmm. So as people are saying, VB VD is equal to root 8 GR, VC is equal to root 6 GR. VC is equal to root 6 GR. VB VT is equal to root 8 GR, VC is equal to 6 GR. Let me tell you, you all are absolutely correct. Pay attention, everyone. As we are going from A to B, so speed should decrease by 2 GR within the root. So VB will be 10 minus 2 will be 8 GR. Similarly, VC will be 8 minus 2. So VC will be root of 6 GR. Now B and D are same points. So that will be root of 8 GR. Alright, so this is VD. This is VD. Now let us talk about tension. You want me to give a shortcut for this also? Okay, at the lowest point, listen carefully. At the lowest point, whatever is the number of velocity, if it is 10, tension will be one more than that. Tension will be one more than that. So it is 10, then tension will be 11. If it is 9, then tension will be 10. Okay, so let us see how it is both ways. We should know the method also. So this is TA, which is upward, mg is downward. Okay, so TA minus mg is equal to mva square by r. So TA comes out to be mva square by r plus mg. So now you got how you are getting one more, because you are adding 1 mg. So that comes out to be 11 mg. So TA is 11 mg. 11 mg. So TB will be 3 less. 3 less means 11 minus 3 will be 8 mg. TC will be now 3 more less. So 5 mg. TD is same as TB, 8 mg. All right. All right. How you are getting Suhas TB and TZ is equal to 9 GR? How you are getting? First of all, it should be mg, not GR. Secondly, your number is different. Suhas. All right. All right. Interesting. Interesting. Sir, TC won't be 0. No, Rubaika, listen carefully. We solved that question was just to complete the vertical circle. Okay, that situation was just to complete the vertical circle. Listen carefully, Rubaika. Okay, not in every case TC will be 0. We derived that just to complete the vertical circle. And what we realized, what we found, that to complete the vertical circle, minimum velocity required at the lowermost point is root 5 GR. Okay, let me write that also as star point. Okay, let me write that also as a star point so that you can remember, everyone. For a particle connected to string, this is very important beginning. For a particle or for an object connected to string. Okay, so string is important. For an object connected to string, to complete the vertical circle, to complete the vertical circle, minimum velocity at the lowest point, excuse me, should be, or you can say must be, minimum velocity at the lowest point must be root 5 GR. Okay, so if at the lowest point it is root 5 GR, then only the object will be able to complete the vertical circle. Otherwise, it will not. Okay. And when you are starting with root 5 GR, tension at the lowest point will be 6 mg. Tension at point B will be 3 mg. And tension at point C will be 0. It will reduce by 3 mg in every quarter. Okay. Remember that. In every quarter, tension reduces by 3 mg. Okay. So a quarter has such soothing effect. That's why many people take it in the evening. All right. So in every quarter, tension reduces by 3 mg. Okay. Very nice. So that condition of Tc is equal to 0 was for this only. In every case, it won't be there. All right. Next question I'm giving for the benefit of public. Question. This time I am giving it in a different way. If TA is equal to 8 mg, find TB, TC, TD, VA, VB, VC, VD. This is A, this is B, this is C, this is D. Please find. Please find. Gauri is saying TB is equal to TD is equal to 5 mg. Okay. TC is equal to 2 mg. Okay. VA is equal to root 7 GR. All right. Hmm. Hmm. Okay, everyone, please pay attention. Mg is acting downward, TA is acting upward, and that is given also. So, all right, pay attention. If TA is 8 mg, I am writing TB as 8 minus 3 is equal to 5 mg. TC is equal to 5 minus 3 is equal to 2 mg. TD is equal to 2 plus 3 is equal to 5 mg. Okay. Okay. Very nice. Now comes velocity. So as I told you very quick, easily that if velocity is, let's say, x, then tension will be x plus 1. So velocity you can directly write as VA. So tension is 8. So 8 minus 1 will be root of 7 GR. If you say no, no, sir, we don't want such methods directly. We want to solve systematically. All right. So TA minus mg is equal to mVA square by R. TA is 8 mg minus mg is equal to mVA square by R. So VA comes out to be root of 7 GR. Okay. So we can solve it like this also. So now if this is this, so VB will be root of 7 minus 2 will be 5 GR. VC will be 5 minus 2 will be root 3 GR. And so on. VD will be root 5 GR. Understood? Understood? Good. 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 All right. Any doubt, any question? All right. All right. All right. Let us move further. Let us move further. Question. Question. And the question says, there is a particle of mass m. It is connected to a string. Okay, radius is r. This point is, let's say, O. Now at a point, which is the lowest point, velocity is given as root of 3 gr. All right. So let me write the question. If velocity at lowest point, if velocity at lowest point is given as root 3 gr, then find angle rotated by string, rotated by string before it slacks. So basically at some point string will slack. Now let me tell you the technical meaning of string getting slack, and that is the tension in string will become 0. Okay, if string is becoming loose, then tension in string will become 0 at that point. So the question is, how much angle will be rotated by the string before the tension in it becomes 0? All right, please find. Those who are giving answer as 90°, let me tell them that in every quarter speed is reduced by 2 gr. So that means in 90° rotation speed should be reduced by 2 gr. So velocity will not become 0 at that point. Okay, it will have some more velocity. So that means it will go further up. It will go further up. So angle will not be 90°. Okay. Gauri has changed the answer and now she's saying phi is equal to cos inverse 1 by 3. Chrisley is saying 120°. Suhas is saying cos inverse 1 by 3. Vedant is saying cos inverse 1 by 3. Asmita is even saying cos theta is equal to 1 by 3 is equal to 70°. Hmm. Okay. Those who are saying 70° are actually wrong because Anyway, the angle will be more. Everyone, please pay attention. Enough time given. Enough time given. Pay attention. So, as I told you that by the time it will reach here, its velocity will be how much left? Root gr. Okay, and that point is P, B. Now, after that, suppose it reaches up to this point at point P, and here the string slacks. I'm not saying that velocity is becoming zero at that point. So velocity, let's say it is Vp, okay, and the string is slacking. So what we can do, we can apply MEC. So by MEC, so PEA plus KEA is equal to PEP plus KEP. Now PEA, I am considering this line as reference line. So PEA is 0 plus KEA half m root of 3 gr whole square is equal to PEP. Now listen carefully everyone. Listen carefully everyone. I am considering this angle as theta, or let's say alpha. Let me take this angle as alpha. Okay. So this height will be how much? R cos alpha from here. Okay. So PEP will be mg and h will be r plus r cos alpha. Plus r cos alpha. And KEP will be half Vp square. KEP will be half m Vp square. So m got cancelled, and you will get this half, and this will become 2. So from here what we can see is 3gr on this side is equal to 2gr plus 2gr cos alpha plus Vp square. Okay, so Vp square is equal to 3gr minus 2gr will be gr minus 2gr cos alpha. This is equation number 1. This is equation number 1. All right. Now comes the next thing by Newton's law at point P. So when we are applying Newton's law at point P, mg will be acting like this. Mg will be acting like this. All right. So if this angle is alpha, this will be alpha. So this will be mg cos alpha. Okay. So now pay attention. By Newton's law, or you can say second law, at point P. So tension will be acting towards the center because tension is a pull type force. So Tp plus mg cos alpha is equal to, now these two forces are going to provide necessary centripetal force because the motion is circular. So that will be mvp square by r. Now as per the question, string slacks at that point. That means tension will become 0. So what do you get from here? Vp square is equal to gr cos alpha. This is equation number 2. This is equation number 2. So equation 1 is also giving value of Vp square. Equation 2 is also giving value of Vp square. Can we compare them? Obviously. So from 1 and 2. From 1 and 2. So what we can see is gr minus 2gr cos alpha is equal to gr cos alpha. So So GR got cancelled. 1 is equal to 3 cos alpha. Cos alpha is equal to 1 by 3. Alpha is equal to cos inverse 1 by 3. Now, my dear friends, and what I want to say is that the angle rotated is not alpha. Angle rotated is theta. So theta will be pi minus alpha. Theta will be pi minus alpha. So answer will be theta is equal to pi minus alpha, and that gives us theta is equal to pi minus cos inverse 1 by 3. This is the answer. This is the answer. Please note, everyone. Please note. Okay, everyone. Any doubt, any question? No doubt, no question. All right. All right. Next question. Good. So this is a circular path, as you can see, and then there is a block of mass m, and this whole thing is smooth, and this height is h. All right, this radius is r. So question is find minimum value of h such that block is able to complete vertical circle. Block is able to complete vertical circle. Please find. All right, people are saying 5r by 2. Vedant is saying, sir, reference line in previous question was lowest point, right? Yes. Yes, Vedant. You should have asked that question at that moment only, but that is fine. Reference line was at the lowest point only. Jared is saying 5r by w. What is this w, Jared? Everyone, please pay attention. Okay, w has become 2. Pay attention. By MEC. So we have two choices. No problem. We have two choices. This point is A, this point is B. We can apply MEC between, let's say this point is O, initial point. Okay. We can apply MEC between O and A, and we can apply MEC between O and B also. So between which 2 points we want to apply MEC? OA or OB? OA or OB? Let me apply between O and A. So by MEC between O and A. By MEC between O and A. Okay. So this is reference line. So PEO plus KEO is equal to PEA plus KEA. Okay. So PEO is MGH, KEO 0 is equal to PEA 0 because it is on the reference line. KEA, we know that for an object to perform vertical circular motion, the minimum velocity at the lowest point should be root 5 gr. So half m root 5 gr whole square. That will be m got cancelled. So GH is equal to half into 5 gr. Again GG got cancelled. So H is equal to 5r by 2. 5r by 2. If we would have applied between point O and B, just to tell you everyone, if we would have applied between point O and B, then velocity at point B would have been root gr, and height of point B will be 2r from the reference line. You will get exactly same answer. You will get exactly same answer. All right. Next question. I hope you all have noted. Next question. So there is a circle which you can see, or actually it is a sphere, and then there is a block. Okay. This is center C and radius is R. So this sphere is smooth. Okay. So if block start starts slipping, find angle rotated by line CA. C is the center and A is the point which is connecting center to mass. Find angle rotated by line CA before block loses contact with the sphere, sphere. Okay, and sphere is smooth, so you don't need to worry about friction. You don't need to worry about friction. Cos inverse 2 by 3. Gauri is saying that. Just to tell you all, this is the easiest topic in entire physics, except if you don't consider these small questions which are here, because just a little bit of understanding and you'll be able to solve questions very easily and confidently in exam with least amount of time. Okay, so solve good number of questions on this so that it becomes firmly established in your system. Suhas is saying pi by 2 plus sine inverse 1 by 3. Okay, everyone, enough time given. Pay attention. Suhas has deleted his answer. That's so sad. Pay attention, everyone. Pay attention. So we are assuming that it will reach somewhere here, rotating an angle theta, and then it will say bye bye m. Okay. After reaching to this point P, it will say bye bye. Now, velocity at this point will be Vp. We have two things to apply. In any of such questions, we have two things to apply. One is MEC and other one is Newton's law of motion. Okay. So what I am doing, I am considering this line as reference line. Line passing through center and diametric axis basically. Okay. So by MEC. By MEC. Now PEA plus KEA is equal to PEP plus KEP. PEA is mgr. KEA is 0. PEP mg r cos theta. KEP, that's what we are trying to find. Half m VP square. So that gives us m cancelled, and that gives us Vp square is equal to 2 gr 1 minus cos theta. Equation number 1. Now let us talk about mass m and Newton's law. Mg will be, let me use red color. Mg will be acting vertically downward. This is theta, this will also be theta. N will be acting perpendicular to the surface. Mg cos theta will be towards center and mg sine theta will be in tangential direction, though it will be useless. So by Newton's law, at point P, what we can do is mg cos theta, which is towards center, minus n, which is away from the center, is equal to mvp square by r. mvp square by r, right? Now, as the question has already mentioned that the block loses contact with the sphere. Block leaves the contact with the sphere. Now, what do we mean by leaving contact with the sphere? The simple thing is n will become 0. The simple thing is n will become 0. So m cancelled. So from here we got Vp square is equal to gr cos theta. This is equation number 2. Now if you see, then equation 1 and equation 2 both are giving value of Vp square. Let us compare them. So from 1 and 2, from 1 and 2. So 2gr into 1 minus cos theta is equal to gr cos theta, and this gr got cancelled. So 2 minus 2 cos theta is equal to cos theta. That means 3 cos theta is equal to 2. Cos theta is equal to 2 by 3. And that gives us theta is equal to cos inverse 2 by 3. That is the answer. That is the answer. Okay. Please note everyone. Please note. No, Mayank, why to subtract cos inverse 2 by 3 from pi by 2? No need to subtract. No need to subtract. Any doubt, any question? Good. Good. Next question. And this time I am giving you a question to solve. And the thing is, okay. This time it is a rod. Okay. Length is R. This is center O. Mass is connected to the end of rod, and that is M. This is A. This is VA. Okay. Now the question says find minimum value. Find minimum value given to the mass M connected to a massless rod. Find minimum value given to mass M connected to a massless rod. This minimum value of V, okay, or you can say VA. Find minimum value of VA given to mass M connected to rod at point A such that it is able to complete vertical circle. Okay, please solve. This time it is rod, not string. Okay, this time it is a rod and not a string. Hmm. Suhas is saying root 4 GR. Chirag is saying 2 root GR. Mayank is saying root 4 GR. Hmm. Okay, everyone, please pay attention. Please pay attention. This is TA. Okay. This is mg, though it is of no use. Let us go to point B, which is again of no use. This is point C. This is of use. All right. Now, by MEC, between point A and C, I am considering this line as a reference line. Okay, bottommost line as reference line. So PEA plus KEA is equal to PEC plus KEC. All right. Now PEA half, no, this is 0. PEA is 0. KEA is half MVA square. Now PEC, C point is how much above the reference line? 2R. So mg into 2R plus KEC, kinetic energy at C. Now listen very carefully everyone. Listen very carefully. The object is connected to a rod. Object is tied to a rod. If it is just able to reach to the topmost point, rod will able to balance the mass and velocity can be 0 at point C. So this will be 0. This is the interesting point and the most you can say significant point in this question, that when the mass is connected to a rod at topmost point velocity can be 0. At topmost point velocity can be 0. Why? Try to understand. In earlier case the mass was connected to a string. So if velocity becomes 0 at the topmost point, mass will fall. Mass will fall and it will not be able to complete the vertical circle. Correct? But here in this case, as it is connected to a rod, it will not fall because rod will not bend. Okay, rod will not allow it to fall. Even if the mass is falling, as it is connected to rod, it will be able to complete the vertical circle. All right. So this is the most crucial step here, and that gives us VA is equal to root of 4 GR. My suggestion to you all is to let the answer written like this only. VA is equal to root 4 GR. Okay. VA is equal to root 4 GR. Why I am saying so? Because using this, we can find values at other points also. How much will be VB? Obviously reduced to, so VB will be under the root of 2GR. VC will be how much? Reduced to, so 2GR minus root of 2GR 0. VD, D is nothing but same. So VD will be root of 2GR. Okay, now comes tension. So if VA is equal to root of 4GR, TA will be 5 mg. You can calculate also. You can calculate also. TA minus mg is equal to MVA square by R. So that will give you TA is equal to 5 mg. Now how much will be TB? So 5 minus 3 will be 2 mg. How much will be TC? Listen very carefully. TC comes out to be minus mg. What is significance of this minus mg? That means the tension at point C is upward, not downward. Why? Because it is a rod. It can push. It can push. A string cannot push. That's why in string tension cannot be negative. But for a rod, you can push also, you can pull also. All right? बात समझ में आ रहा है? So as it is a rod, it can exert force in both the direction. Pull type also as well as push type also. So basically TC will be in upward direction. And that TC, let me tell you, that TC is balancing mg. That TC is balancing the mass of object. Okay, so mg is acting downward and that mg is balanced by tension in the rod. So that is holding the mass mg. Okay, understood? Any doubt, any question? So remember these values. Okay, remember these values. Now what is difference between first case when it is connected to a string and second case when it is connected to a rod? Let me tell you. When it is connected to a string, the object has freedom to leave the vertical circle. Okay, if at any point tension becomes 0, object can leave the vertical circle. If at any point normal reaction becomes 0, object can leave the vertical circle. We have seen the examples also. But in this case, as it is connected to a rod, it cannot leave the vertical circle. It will remain on the vertical circle always. Whatever is the velocity given, whether it is less or more, object will all its life remain in the vertical circle. That is the difference. Okay. In this case, object is bound to remain in vertical circle. But when it was connected to a string, it was not mandatory for the object to remain in vertical circle. It was free to leave if situations are not favorable. All right. So we'll continue this topic in the next class. That is enough for today. Thank you so much.